Hi, welcome back. So I've changed a few things. I'll take you through that quickly before we move on to our other effects. One thing is I just named these EMP here. I didn't put EMP at the start, but just to make sure that we differentiate this completely from our decloaking effects. And then I've written out our point cloud for the environment here and our spheres, so we can easily access what our shockwave is, and this is just the 3 spheres expanding with an attribute transfer over there. I've also fixed the material. I was just pointing to the matnet before for our volume instead of pointing directly into the actual shader. So that's done. So before we move on to the other effects, I just want to explain a little bit about my thought process now moving ahead. So with the previous effects, we were usually pretty good at, say, doing 2 or 3 of these layers and then starting to render them out and comp them. In this case, we've got such a simple setup here of just a highly reflective sphere expanding and then this fog on the inside. I feel like because I have a lot of things in my head for how I want this to look, there's not enough to work with in the comp. So there's an element of 2 things going on. One is look dev. So essentially, while I have a lot of ideas, I don't know exactly what I want the end product to look like. So in that sense, let's make as many cool looking layers as we can and then just render them all out and pick and choose in the comp what we think works well. Another thing is I do sometimes work this way, but mostly if I'm under pressure to get something done quickly, that's why I start rendering out stuff and comping immediately so I can make sure everything's working as I go. Like I said, in this case, it's kind of like a bit of an open-ended effect with no clear finished product in mind. So for now, I just want to keep dropping down the stuff I know we want. And one is an electrical reaction between the sphere and the ground, and probably some other electrical elements flying off the drone as well, similar to the reference we've been looking at. So I definitely need something like that in, and I'll need that light to also affect the volume, I think, so we need to do that. Next, we need to add some interaction on the actual environment from the sphere. So taking our point cloud or our velocity from the sphere, we can source some dust and have some dust reacting to the sphere here and along the walls. And I also know I want to add a magical element expanding from the drone to fill up this kind of void that's going to be left behind after the shield passes, after the EMP passes the camera. So there's a bunch of stuff that I want to do as a sort of base before we even try and assemble this together in comp. So for now, let's just go ahead and start with the ground-based electricity. So I'll put down a geo. Let's call it electro. And no matter how many electrical type of layers we do, we can just try and get that all to work inside here. And I'll probably see if I can copy anything over from our arc setup as well. So for now, all I need is basically a source that exists wherever the sphere is touching the environment. So I'm going to load in the shockwave first. So there's our shockwave. I'll just make that white. And then same thing with the environment, and I can actually use the point cloud I saved to give us a higher resolution selection of points there for our attribute transfer here. So let's set that to black. And then our sphere does have velocity, so let's transfer velocity and color. So I just want a very small selection around where the sphere is touching the environment. So just the thinnest possible selection of points there. So something like that should work. It's a bit slow here because the attribute transfer is slow with so many points to try and use. That looks pretty cool. So I'll need to cache this out at some point. Right, so we've got that. So I'm just going to delete all black points. And we can use this as a source now to source some particles. So let me first change the start frame here to 170. That should do it. And then over here inside the pop, I will set this to all points. Just give some life there. So I just play every now and again to make sure everything's working. And this is not what I want because we've inherited the velocity. So now those points are shooting out in the direction that the spheres are expanding, which is also kind of cool, but it's not going to be helpful for us. I don't want anything to be moving through the walls. I want it to be left behind on the wall. So I'm just going to switch off inherit velocity. So we just get some points that are left behind there. And just to make sure we get loads of variance here, and the reason is because I'm just going to basically keep all of these points and really fill up this leading edge of the shockwave with electricity. So there's going to be a lot of information here. So we need to really make sure there's variation at every step. So I'm going to add a shorter lifespan with a bit of variance here, so at least we start with a variance in life. But we need to keep that in mind and add variance as much as we can as we go along. Right, so before I copy lines on here, let me actually just cache this for the next time I play it. And let's set some initial attributes just for our lines. So for starters, I can't just copy lines and do random in the rotation like we did last time, because that would just result in basically like something similar to the matrix reference we were looking at, where there were pockets of very random noisy electricity. So not a huge fan of that, and I definitely want something to feel like it's still in the direction of its source. So I want these arcs to be pointing back towards the drone. So let's put down a wrangle, and I'm just going to update the normal here to be the same as the velocity. I'm not seeing anything. I think I do have velocity there. Yes, because I switched it off in the pop. So I'll just set this to something super low. So hopefully our points don't actually move too much, but they should have that information, that vector direction that we need. There we go. So here we have normals based on the expanding velocity of our sphere, and I actually want these to be negative. So that's a pretty cool effect. So that gives us a direction for our lines. So let's take that. Can we add anything else? I think we should do a color. And we can ramp that based on age divided by life. So we've done a few of these steps before, and I'm just trying to recreate that for this effect here. So the basics is I've got particles. So now I have enough information to tweak a bunch of that stuff using the age. So let's go for like a bright at the start, and we can use this to allow our arcs to kind of fall off in intensity. So just do a kind of exaggerated drop off there, so they sort of bright and then darken down. Super cool looking at this from a wide camera. Kind of makes me wish we were doing a super wide shot. Okay, so let's run with that for now, and let's copy our lines onto these points. So I'll just make a line, make sure it's oriented in Z, and copy. Okay, and I'm just going to immediately put in another random number over here based on ID between, let's say that's the smallest, so we say 1 and 5 times longer. So now we're starting to get some good variation. Right, so let's see what we can pillage now from our arc setup, because we have something similar going on here. So we should be able to grab something useful. So for starters, this ray, so we ray to the environment, we resampled it, we rayed again, we resampled again, and got our curve view attribute, and we got our noise over here. So let's grab all of that. So we don't even need this first resample because there's only 2 points for each line here, and I want the whole line to be attached to the environment. So let's actually bring in the environment here. Okay, so that will be our collider. So we just ray those points down. But we are missing a second ray, because I used 2 rays before to get the arc to kind of try and reattach itself to the environment. Let's leave it like this and see how it goes. So now we have points moving through the environment, some lines, and those lines are getting stuck to things So that's exactly what we want. Let me make sure I'm taking my attributes through the copy. So that's the electricity dying over there. Then we've got another resample and then our noise. So the same noise we used for the arc in the close-up shot is not going to be good enough to use for the super wide here. So we'll need to change that, and again, there's more stuff we could be doing to make sure that there's a lot of variation in this electricity. So I think I'm actually going to just rebuild this, and we'll start from the ground up with some variation in mind. So let's just do the basics first. So we'll put down our turbulent noise, make sure that's set to 3D, and I like using sparse. And what do we need? We just need to add that to P. Okay, so way too high frequency. So I'm just sort of eyeballing this at the moment, and you have to decide what you think looks like a good value given the actual camera. So it's unrealistic to maybe change too much if you're changing, say, the camera length in the shot and deciding between different effects, something should have a different frequency. But at the same time, these arcs are much longer than the ones that were on our drone. So I still need to choose a value for our noise that feels right, given the scale. So something that gives us some kind of overall shape that looks good in shot. So we have a noise, we're adding that to P. And let's start adding some variation. So first off, let's make sure we have our age divided by life. Put that through a ramp. And let's just start by getting that into our amplitude. So we want the amplitude to be a little bit, and then to quickly rise towards the end, and then go very high before our line dies. So I'm just watching each line here to see how it looks. And I'm already not happy with the amount of variation in our length. I'm going to come back up here and let's add in a second wrangle before we carry on with the noise, and just add some variation to our length. So I'll take P scale. And let's base that off. Let's use a ramp again. So in this case, it's going to give us a lot more freedom to choose the percentage of the amount of lines that are affected by this random number. So we'll put in a rand by ID. Okay, so here we get a lot of options because every single one of these points IDs is fitting in between this ramp. So there's like 1,000,000 points, and maybe somewhere you make sure some of those IDs are long. So we can do that, making sure that we have some kind of base length. So actually I'm going to set this to multiply this by 10. So multiply the whole thing by 10 and stick with some low values here, so 0.1. So this is at the moment amounting to the same length. But now we have some room to grow these lines in very specific amounts or percentages. So here's what we have. So let's put in a few more 0.1s. So I hope that makes sense. It's basically, we're still just picking a random number based on the ID, but we're sticking that inside a ramp. So now imagine this is full of IDs, and we can just take this one over here and put a peak there. And now we've just taken a few of those IDs and made those longer. So it gives us options for what percentage of the lines we would like to increase the length of. So it doesn't look like we need to go very high. But we're already getting way more variation, and what I kind of like about this is we're getting some extremely long lines. So 10 was probably too much, but having these long lines in the scene is maybe quite beneficial. So we just need to see how that plays here when we get the noise working. Right, so at the moment we've got the age divided by life in a ramp, and we're plugging that into the amplitude of the noise. So I'm not really seeing that too much. I'm seeing it on the small ones. You can see the amplitude taking effect over here. But the big ones, it's happening very little. So I can come back here and say multiply, if we multiply age by p-scale, then we make sure that the short ones are still at 0.1 times 10, so they are unchanged, and anything that goes larger, like here, our age goes up as well. So if we have a set lifespan, which we do, and we're making our age go up faster, then that effect goes faster. So why is this breaking? So basically, my lines that are super long here, I'm not seeing the difference in the amplitude. I guess because they're too long. So I'm taking the age and I'm making the age of these lines happen faster. So if that makes sense, then what we get here is the age divided by life. On long lines or points with a high p-scale, this will give us a faster output. So here our age will meet our life much sooner. So we put that through the ramp, and now we're getting a quicker reaction. So the long lines are reacting so fast now that it's too fast, because they're not dying in time, or the age has reached the life, and so the amplitude is at its max, but the point hasn't actually died. But that's okay for now. So it looks pretty cool actually. So we've got some variation now in the length, and we have a reaction with the noise and the amplitude. So pretty quick setup there, and we're getting some decent variation. So let's jump back in here and see what else we can do. So for starters, I could even add add something random to this ramp. So we could take the ID again, randomize it, and add the value to the ramp. And we can fit that between a set value. So pick a random ID, then set that to say 0.75 and 1.5. Then every time this runs through an ID, it'll choose a random number between 0.75 and 1.5 and add that. So here's another couple of values we can play with until we're happy. It's all getting a bit much here. Or we can adjust the maximum noise afterwards. We're just trying to make sure we get some variation. I mean, I can even take that ID and just plug it into the offset to make sure that because you saw here, if I just increase, let me put down a multiply. So if we multiply, this is our amplitude ramp. So if you see when I scale up the amplitude, some of the noises or some of the lines are following in the same noise. So for example, this bunch of lines here, they kind of want to go the same direction because that's based on the scale or frequency of our noise. So let me just lower this. And so just by plugging in a ID, each one of those lines has a unique ID. So now each one of those lines will have a unique offset in the noise. So it doesn't matter how high we go, they each have their own noise position. And then we can multiply this back down by the same range. I think we just need to really reduce the amount of noise we're adding here. So this is looking pretty decent over here, but at the start it's too straight. So I can just come back to my ramp. Something like that. So we just want to make sure it still has some noise, but still has room to expand, but not go so far on the expansion of the amplitude that it becomes a noisy mess. Which it does feel like it's kind of becoming a noisy mess here, but that's because we're looking at the super dark lines as well. So I mean that's the basis of this arc setup done. I think we're getting loads of randomness, and I'm gonna duplicate this random number from our ID, and let's take the color and multiply that by this random number as well. So now we're getting even more variation here in the intensity of it. And I'm going to do the same thing here and just take the color, and we'll have values over 1 now. So I'll do a length and a clamp between 0 and 1 because I want to export an alpha. So if you remember the decloak effect, we've done that arc setup, and essentially this is the same, except I'm just playing around with the options we have to exaggerate variation. So using that ID quite a lot here to get random numbers, choose some values that those numbers have, and use those to affect one, the amplitude, to affect the color, and using the ID to even affect the offset, and just combining those in ways that add more randomness. So I'm just trying to decide if this is enough or too much. Right, so something like that. And let me just experiment quick with an extra ray. So if we rayed this down and we resampled and then rayed it down again, so it does kind of help because it's pushing everything slightly back in. And if I rayed the second ray on a lower scale, I could even make that sort of look like it's trying to get closer, but it's not actually going all the way. Right, so these now have color and alpha and a pretty drastic variation in the length. So I'm feeling pretty good about that. Let's take this now and quickly add some color before I finish up. So we'll say CD equals another ramp. It's all ramps with me. Based on CDX. And let's throw in some, oh, we don't have a color, so I need to make a color ramp. I can't actually remember how to make a color ramp in a Wrangle here. I might have to check that out. For now, let's do this in a VOP. You guys will probably know how to do it. I'll have a look. So I just want a ramp using the color, and we'll have, once again, my nice blue. And you know, we can add a bit more variation here while we're at it. I'll get this dark blue going down to here, and then basically do it again. So if we compare these, and I do something like that, now some of the dark ones that are dying might flash white, or even some other random combination that might not have been seen here, we're getting over there. So even more. So I need to go and study up on my wrangles a little bit. Let's do a quick flip book and see where we're at with this effect here. Trying to find a good way to visualize these kind of lines can be difficult. Just go with that. Okay, so now we know the timing is right because we have the timing of the electricity based off of our spheres, so that's fine. And the source is based off the sphere's edge, so these arcs will be running directly behind that. We can definitely see some of the amplitude based on age happening. And we're getting that interesting effect of the lines actually going bright, then dark, and then bright again from that color ramp. So it's very intense at the moment, but I am seeing quite a lot of dark lines as well. So it will probably look a bit cleaner once we render this properly with an alpha. But I'm thinking now maybe I'll be tweaking the noise a little bit, bringing it down, just reining it in. In terms of the length, I think it's fine. I think it's just balancing the amount of noise and amplitude and making sure that this alpha is working correctly. And I can try and preview that by just knocking this back. So that's a bit more representative of what we should be seeing without seeing the dark lines as well. So I think that looks pretty cool. Let me go through that and clean it up. You can see here it's interacting with the car. We'll clean it up. I might need to add another ramp somewhere. But in the next video anyway, I want to do the expanding arcs that come from the drone itself as well. So similar to the Pacific Rim reference we were looking at, there's the sense that there's like arcs that are kind of attached both to the character and then to the edge of the spheres themselves. So this is more of like trying to get an interaction between the sphere and the environment. And now I want something connecting the drone to the sphere as well. So I will see you guys in the next video.